Okay, standard index form or just standard form. Some conversions to do between numbers and standard index form and vice versa, and then some calculations. We use standard form to write more effectively either very big numbers or very small numbers, and then use that method of representing the number to make calculations easier. And some previous background knowledge, we need to know, and I'm pretty sure that you do, 10 to the 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1000, and so on. The index refers to how many zeros there are after the 1. So 10 to the 2 is 100, that's a 1 with 2 zeros. 10 to the 3 is a 1 with 3 zeros. 10 to the minus 1, a minus index of 10, tells me where the 1 is after the decimal point, how many places after the decimal point I've got to put my 1. So minus 1, 1 place, minus 2, 2 places, minus 3, 3 places, and so on. Okay, 4.86, we've got to write that as times 10 to the minus 2, we've got to write that as a number. So we do that by writing the 486 with a few zeros in front of it. But this standard form says I've got to write 486 times 10 to the minus 2. I've got to make 486 100 times smaller. So there was my decimal point. I've got to move my decimal point 2 places to the left to make my number smaller, because I'm multiplying by 10 to the minus 2 or dividing by 100. Okay, next one, the other way around. 4,210,000, write that in standard index form. Well, the mantissa part, the number part, needs to be a number between 1 and 9.9 recurrent, and then multiply that number by 10 to the power of something to show how big it is or how small it is. So this 4,210,000 is actually 4.21 times 10 to the power of something, and the power we get by putting the decimal point in at the end of the number and then seeing how many places I've got to move it. So we move it once, twice, 3, 4, 5, 6 times. And so I need to multiply 4.21 by 10 to the power of 6 to make it into 4,210,000. And that's it. Okay, and now we're going to do 3 calculations. We've got a takeaway, and we've got a times, and we've got a divide. And the first one, takeaway, 3.2 times 10 to the 6, take away 1.8 times 10 to the 5, with the answer in standard index form. The problem here is I've got 2 different powers of 10, 10 to the 6 and 10 to the 5. So the first thing I need to do is to convert them both to the same power of 10. So there are a couple of ways of doing this. I'm choosing this way so I can show something in particular. The 32 times 10 to the 5 is the same as 3.2 times 10 to the 6. I've used one of my powers of 10 to change my 3.2 into 32. So I've got to reduce my 10 to the 6 by 10, so it's 10 to the power of 5. 32 times 10 to the 5 is exactly the same value number as 3.2 times 10 to the 6. So now I can do 32 take away 1.8, which is 30.2, and times that by 10 to the power of 5. The problem is that this 30.2 is not a number between 1 and 9.9 recurring. But if I divide 30.2 by 10, I get 3.02, and that is between 1 and 9.9 recurring. So because I've divided this by 10 to the power of 1, I've got to multiply my 10 to the power of 5 by 10 to the power of 1 to make it 10 to the power of 6. So those two numbers have got the same value. 30.2 times 10 to the 5 is not standard form, but this one is, and they're the same. Both of those are the same value. Next one. Calculate 4.1 times 10 to the 7 times 3.2 times 10 to the 4. And this is where standard form comes into its own, because it doesn't matter which order I do my multiplies in. So I'm going to change the order and make it into 4.1 times 3.2, and then times that by 10 to the 7 times 10 to the 4. And it's this part, the 10 to the 7 times 10 to the 4, which makes standard form really, really quite powerful, because it's a number to a power times the same number to a different power, so I can just add the powers together. So and then I do 4.1 times 3.2, which is 13.12 times 10 to the 11. So there's our answer, except that it's not in standard form. This again, like that previous example, needs to be between 1 and 9.9 recurring. So now I've got to do that one divided by 10 to the power of 1, which is 1.312. So I need to multiply this one by 10 to the power of 1 to give 10 to the power of 12. So that both of those two numbers, 1312 times 10 to the 11, is the same value as 1.312 times 10 to the 12. It's just that this one is correct standard form. And that's it. And the last one's a division. So we've got 3.9 times 10 to the 4 divided by 1.2 times 10 to the minus 2. Okay, both of those are in standard form. We've got to give the answer in standard form as well. And I'm going to do exactly the same as I did in the previous example. I'm going to split my mantises, the 3.9 and the 1.2. I'm going to split the 10 to the power of 4 and the 10 to the minus 2. And so that's my calculation. 3.9 divided by 1.2 is 3.25, and that's already in standard form. That's already between 1 and 9.9 recurring, and so all I need to do is find out what power of 10 I've got to multiply that by to move my number to the right size. And 10 to the 4 divided by 10 to the minus 2 is a number to a power divided by the same number to a different power, so I do 4 take away minus 2, which is 10 to the power of 6, and it's as easy as that. So there's some examples of standard form, converting between number and standard form and vice versa, a takeaway, a times, and a divide. Hope that's been useful for you. Please check out my other videos. Goodbye for now.